Lesson 511, Unit Iteration for Angles. In this lesson, I want you to consider the need for a standard unit of measure. I want you to examine an angle measuring 1 degree and mark benchmark angles on a circle. You're going to use those benchmark angles to estimate the measure of angles. But first, let's start with our mental math and fluency. It asks, 1 kilometer is 1,000 meters. Based on that information, how many meters are in 6 kilometers? Well, remember, in place of 1, we'd put a 6 here. So 6 times 1,000 is what? 6,000. 45 kilometers. Again, we're putting 45 here. So how'd you do the last one? You multiplied it by 1,000. So 45 times 1,000 is 45,000. And 83 kilometers equals what? Well, 83 times 1,000 is 83,000 meters. For this next part, I would like you to get out Math Masters page TA47. It says, Kian used purple wedges to measure an angle. Letitia measured the same angle using light green wedges. Kian said the angle's measurement was 5 wedges. Letitia said the angle's measurement was 6 wedges. Who's correct? And how do you know? Well, hopefully you got out your angles. And to tell you the truth, that neither one can really tell if it's correct because they measured the angle with different size wedges. Remember, whenever you're going to measure something, you need a standard unit in order to measure. So you need to name some standard unit of measure in the U.S. customary or metric system. For instance, we measure either with inches, centimeters, feet, gallon, liters, maybe a pound. So in order for us to be able to measure, we need to measure in something in an angle called a degree. A degree is the measure of a very small angle. So what you're seeing here, that little circle there, is the symbol for degrees. So the angle measurements can be written using the word as in 1 degree. So you could write the word out as 1 and then write the degree word after it. Or instead of writing out the word degree, you could just use the symbol 1. They are equal, meaning that if somebody asked you to write 1 degree, if you wrote it in words, that would be correct. And if you wrote it with the symbol, that would be correct. Angle measurement. I want you to turn to Math Journal page 182. And I want to explain something to you on page 182. It says, connect 2 straws with a twist tie. Bend the twist tie at the connection to form a vertex. So you're bending it in the middle where it connects. Place the straws with the vertex on the center of the circle. Place both straws pointing to 0 degrees. Keep one straw at all times pointing to 0 degrees, but move the other straw to form angles. So your vertex is going to be here. If you would start with both straws, and I want you to get the straws, but I'm going to show you, you would want to draw this and lay it down to the vertex. And then if you laid the other straw out to this area, this would be at 90 degrees. So if you were going to draw an angle that was halfway between 0 and 90, you would want to measure it to make sure it's accurate. But approximately this would be where it would be at, and halfway between 0 and 90, if you were looking at a number line, would be 45. And again, if you were looking at 1 degree, roughly, you would have the other, and sorry this is so crooked, you would have the other straw approximately there, and this would be at 1 degree. Remember, if that's 90, another 90 would make the arrow straight up and down. Your straws, I'm sorry. That would be 180 degrees. And if I took that same and now turned it this way, clockwise, and laid it perfectly straight across, this would be 270 degrees. And if I took this same straw and brought it all the way back up to meet my original straw, I would say that I did a 360 degree turn. That's how that is done. So a quarter turn is 90, a half turn is 180, a 3/4 turn is 270, and a full turn. So what measures exactly at 90 degrees? A right angle. Remember, a right angle looks like a perfect capital L. And that capital L could be from 12 to 3. It could be from 3 to where the number 6 would be on a clock. It could be from the number 6 to the number 9 on a clock. Or it could be from the number 9 to the number 12. And sorry, that one's not very good. But those should be perfect capital L's, and you have a 90 degree angle. An acute angle measures less than 90 degrees. So again, looking at this first angle, anything that would land before 90, and I'm sorry, I don't know why this is doing that, before that 90, so even 89 would be considered a acute angle. An obtuse angle measures more than 90, so 91, all the way up to 179. Notice it says it needs to be less than. So an angle that measures greater than 90, but less than 180 is an obtuse angle. And finally, a reflex angle, which I will explain a little further because right now it's not going to explain that to you. So this wants you to turn to Math Journal page 183. You're going to need to pause the recording when I get done reading the instructions because this is an assessment check-in and they are expecting me to check this when you are done to make sure that you understand it. So it says, look at the angles on the next two screens. Decide whether they are acute, right, obtuse, or reflex. Estimate the measure of each angle in degrees. Well, on your Math Journal page, you need to look up in the upper right-hand corner, and it's going to give you a page in your student reference book that you can look at to make sure that you're writing the type down correctly and the estimated measurement down correctly. Remember, you can always rewind this recording if something wasn't thoroughly explained enough for you. Now I am going to read the directions on Math Journal page 183, and it says, look at the angle. Decide whether it is acute, a right angle, an obtuse, or a reflex. That's what's going to go under the type. One of those words, either acute, right, obtuse, or reflex. And then you need to estimate, guess on what I told you earlier about the degrees, and you need to write that here. So if you need to rewind this recording to make sure that you're understanding again what the angles measurements are or about what degrees they are, you may do that. If that doesn't help, get out your student reference book and take a look at those. So here is A. Is A a right, obtuse, or reflex, or acute? And you write that here. And about how many degrees is that? I would probably take a Post-it note and lay it in here and see if that gives you a hint to A. B should be obvious just by looking at it, that it's small, and boy is it cute. So that should give you a hint to what word should go here. Then you need to check it out and see, well, how big is this angle in here versus this angle here? And that should help you to estimate what degrees that angle is. C, take a look back. I drew a straight line with the straws, and I said if it is exactly a straight line, or 179 degrees, it's called this. But anything beyond 180 degrees is called a reflex angle. Again, for D, you're measuring in the inside. But look at for E. It's all the way around the outside. And F again, if you look back at my example that I recorded, you should be able to figure these out. Pause the recording, get out your SRB if you need it, and do page 183. Then bring it up to me so that I can check it. So you should have brought your paper up to me to have me check Math Journal, page 183. But I want you to think about how you estimated the measurement of the angle in degrees. Hopefully you used something that's a perfect right angle, like a Post-it note or the corner of a sheet of paper, and you realize that if it's smaller than that right angle, it's anywhere from 0 to 90 degrees. And if it's larger than 90 but less than 180, you also realize that that's an obtuse angle. And if it's anything greater than 180, you are looking at a reflex angle. So hopefully that's how you estimated the measurement of angles in degrees. As you practice that more, it's going to be a lot easier for you, and it's just going to come naturally. What you're seeing me flip through here are some of the games that we've played in the past, and we're just going to continue on through them. The next step in this unit and lesson is Math Journal, page 181. Math Journal, page 181 is looking at math boxes. So math box 1, you're seeing that you're going to be subtracting fractions. Pause the recording now and do that, please. In math box 2, it says compare the decimals using greater than, less than, or equal to signs. Pause the recording and do math box 2, please. Math box 3 says, Chuck and Miles filled 3/4 of a bag with leaves in the morning. In the afternoon, they filled 3/4 of another bag. In all, how many bags did they fill? So, if you're doing it in all, you should know that you're adding them together. Please realize that there is more than one correct answer to this problem. They're just writing it in different ways. Pause the recording now and do Math Box 3. Math Box 4 reads, the Sunrise food bakers need to order flour. The shelves for flour can only hold 30 kilograms of weight. The bakers ordered 9,641 grams of white flour, 5,309 grams of unbleached flour, 8,962 grams of rye flour, and 5,301 grams of gluten-free flour. How many more grams can the shelf hold? Well, you would set this up as 30 kilograms minus, and then add the 9,000, the 5,000, the 8,000, and the 5,000 together as grams, and then convert it into kilograms to figure out your answer. Pause the recording now, rewind it if you need to hear those directions again. 5 reads, in problem 2b, you compared 9 hundredths to 30 hundredths. How did you decide which answer was larger? Do that one, please, and then check your answers. And if you got any wrong, please bring it up to me. The final thing you will do is Math Masters, page 215. Bring it up to me to check when you're done. And when that's completed, you're done with this lesson.